In this lecture, we'll implement the main invest function. This is the function that is called when somebody sends Ether to our ICO contract and in turn receives cryptos. So here I create another function. In fact, this is the main function of our smart contract, and the function is named invest. This is a payable function. This is because users will send Ether by calling this function. It's a public function and returns a Boolean value. And now the function body. Someone can invest only if our ICO is in the running state. So invest only in running. This means ICO state equals to get current state. So we save in this variable the current state of our ICO. This is the function that returns the ICO state. And now we require that the ICO state is equal to state.running. So require ICO state equals state.running. Then we have other requirements. We said at the beginning that the minimum investment is 0.01 Ether and the maximum investment is 5 Ether. We have two state variables for these values. So here we require that msg.value, this is how much the user sent, is greater than or equal to min investment, and msg.value less than or equal to max investment. So the maximum value allowed in our ICO. Now we declare a local variable, an uint variable named tokens. This variable represents how many tokens, cryptos tokens, will the investor receive. So here I calculate the number of cryptos. And this is equals to msg.value, the amount sent to the ICO, divided by token price. Okay, let me explain. We have here a token price variable. So 1 CRPT equals to this value of Wei. If somebody sends, let's say 1 billion Wei, we can calculate how many cryptos should that account receive by dividing 1 billion to this value. And the result is the number of cryptos. So the number of cryptos is msg.value divided by token price. We still have a requirement. We said that we accept in our ICO not more than 300 Ether. If the hard cap is reached, we don't allow any new Ether investment. Okay, many ICOs also have a soft cap. The soft cap is the amount received at which our crowd sale will be considered a success. It is the minimal amount required by the project. And if a project doesn't reach that amount during the ICO, then the investors will be allowed to retire their apport. We don't use a soft cap at this moment, but it's not complicated or something very difficult to add a soft cap. So here we require that the hard cap has not been reached. So require raised amount, this is the total amount received till this point, plus this value, msg.value, the value sent with this transaction, is less than or equal to hard cap. Okay, further, we add to the raised amount the value sent with this transaction. So raised amount plus equal to msg.value. And now, and this is very important, we add cryptos to the investor's balance and we subtract the same amount of cryptos from the owner or the founder balance. So balances of msg.sender, the account that called the invest function, plus equal to tokens Here I use plus equal to because maybe this is not the first investment of this account. So an account can send some amount of Ether, waits for some time and then invests one more time. So we add to its balance. And here I remind you that when created the Cryptos token, there is a founder that has all the supply. So all Cryptos tokens belong to the founder balance. So this is not the admin. It could be the admin or not. In our example, this is the same address. Because we initialize both the founder and the admin with msg.sender. So here I write balances of founder minus equal to tokens. So here, for clarity, I'll add a comment. What should we do further? We should send this amount of Ether to the deposit address because we don't save the received Ether in the contract balance. It's safer this way. So this is a good security practice. So deposit dot transfer msg dot value. This is very important and this address should be kept secured. Maybe in cold storage. We return true. So everything worked perfectly. There is still something we should do. We should emit an invest event. So here we must save on the blockchain as a log the outcome of this transaction, that an investment has been made. For example, we could have a web application that listens for these events and that application will update its interface. And we can see something like till this moment, let's say 50 Ether have been received and so on. So here I create an event named invest with uppercase I. It's not mandatory, but it's a good practice to call events with an uppercase letter. So invest, address, investor, uint value, uint tokens. And here, inside our invest function, we emit this event. Invest msg.sender, msg.value, tokens. Okay, here we are. The invest function is ready. So, an investor calls this function when sending an amount of Ether, and in return, that investor receives cryptos. But what if an investor sends Ether directly to the contract address? And this is the normal way of investing in an ICO. So what happens then? We should create a fallback payable function. That function will be automatically called when somebody sends Ether directly to the ICO contract. So here I create another function, and this is very simple. You'll see this function doesn't have a name. This is what a fallback function means. It's payable and it's public. And inside this function, I call the invest function we've just defined. So invest. Okay, now there are two possibilities for an investor to participate in our ICO. He can simply send Ether to the contract address, or from a web application or from another decentralized application, that investor can call this function, sending some Ether. In the next lecture, we'll test our ICO, which is almost ready. See you soon.